Alright, hello, welcome back to Hocus Pocus. Today we're gonna be doing some Python things. I don't like most things, I don't intend to go too in-depth into this. This is just I don't know, kind of like a demo, kind of like an explanation, um sort of a display of like how useful and easy programming can be. But without further ado, let's get right into it. Alright, so what we have here is we have Python. We're running this courtesy of Jupyter Lite. You can just access this website and use this notebook like completely for free, like no downloads, no real obligation. But you can run it through your computer if you download some files as well. So it's pretty useful. It's a neat little website, neat little I don't know, system. It's basically an IDE, but it's got individual cells for code separation, ease of use, ease of readability. It doesn't really come together into a functional application though. So, also IDE, integrated development environment. If you want to write proper code into applications or just do larger scale development, that's probably the path you want to do. This is pretty good for running code, testing code, doing small scale things, code separation, that kind of thing. I'm choosing Python for this, specifically because I can run it through Jupyter, and it's also easy to see, it's easy to learn. Yeah, those are the big reasons. It works well for this sort of demo. Some of the downsides of Python. The biggest one is its speed, but that can be mitigated through using some of its libraries or calling external programs that run in C++ or whatever. Let's just get right into it. So these lines, these are calling like external libraries or internal libraries, as the case may be, because Python does come with a lot of them. If you hit Shift Enter in these, then you can run each cell. So I just ran that one for a second time. And then I'm just going to walk through all of these real quick. Okay, so what I have here is I have a couple of little individual programs, little functions that you can call individually. So like for example, this one just takes like a probability that you put into it, and then it converts that into the probability of it not occurring. So if we change the probability variable up here into 0.5, and then we run this, it just it's what's left over if you subtract it from 1. So if we do 0.45, yeah, very simple. And then, you know, the probability of at least one thing occurring. Right here I have it set to the shiny ratio for Pokemon if we were to re-roll it 125 times after the initial one. So I actually used that to help a friend of mine out when we were looking at what the probability of getting a shiny would be if you had this as opposed to a normal shiny charm. So if I were to, I don't know, say we're going to run this 500 times, it's going to recheck it 499 times after the initial just to see if there's going to be a shiny. We're looking at a 30% chance. So like once you have an idea for something that you want to do, you can just front load all of the work if you want to reuse that multiple times with a function like this. So that's really cool. Like it's just like once you have a good flow path, you can just write some code, and then it will take care of each subsequent time that you want to do it. If I wanted to, I don't know, going back to Risk of Rain, if I had 125 iterations of it, I think that in the game you can have 125 instances of an item before it like starts flipping values, or at least it used to. I think when the companies changed hands, they did some different things with the way the items function. So this might be old use, but if we had the maximum number or close to the maximum number of items, you're probably not going to be taking any damage. And then, like, if you were to have an 8-leaf clover, or 38 leaf, or however many it was, you're looking pretty good there. Yeah, I just kind of wanted to go over this and, like, sort of like point some things out, and like if you want to see how probability changes like over time, like if we were to take that previous Risk of Rain example, so like you can see pretty easily, like from the graphical representation, that you get the most value out of the initial ones that you have, right? So you get one that's 10%, you get two that's 19, you get three that's about 27, right? So as you get more, the impact of each one lessens, and like using like graphical methods and fairly simple functions is a good way to like understand and visualize how the different mathematical formulas actually work and how they change over time. So it's very useful, and in my opinion it's really cool. Right? And like a lot of these things are things that you can double check, or that the Python libraries will have like options for, like I'm reasonably certain that if you want to be able to determine if something is prime, you don't need to write your own function for it, probably. But yeah, like I think I may have actually mixed these two up, because 24 is not prime, so it's probably going to return true if it's divisible by anything. I think I'm misspelling that. That's fine. I don't care. Woo! Okay. I didn't really want to go too deep into how to code, but I hope that this kind of serves as like a good I don't know, a good demonstration of how useful like even very simple coding can be. Sorry about the notification noise. Yeah, I hope that this serves as a good demonstration of how like easy and useful simple applications of programming can be. If you have any questions, comments, ideas, thoughts, or concerns, please leave them below. But without further ado, this was Hocus Focus, and I hope that you have a wonderful day.